Today, we will explain how we evaluate the emission amount of radioactive materials from the reactor buildings of Units 1 to 3 at Fukushima Daiichi nuclear power station. Last week, we explained how we measure radioactive materials in the site. Today, we will explain how we evaluate the emission amount of radioactive materials from reactor buildings. The results will be announced in the roadmap meeting every month. Specifically, we will explain the concrete methods and the data we used for the evaluation. First of all, we have been conducting 6 types of radiation samplings in and around the site. First, with regard to the density measurements of the dust in the sites, we conduct and analyze at the point of the west gate and the monitoring post number 1, and once a week analyze the dust in the air in the site. The second is the dust analysis over the reactor buildings, which is the main theme today. The third is the measurement of the dust density over the sea. This is done because we believe that we can measure and analyze radiation better than on the ground, as radioactive materials over the sea do not soar once they fall down on the surface. The fourth is the measurement of radioactive dust in the site. We measure radioactive materials in the air that fall down into a flower bowl. The fifth is the measurement of water in the sub-drainage. This water is pumped from the basement around the buildings. The main purpose is to confirm that highly concentrated contaminated water in the buildings does not leak into the groundwater. The last one is the measurement of seawater. The purpose is to confirm the current impact of the radioactive materials that have been released into the ocean. We have been doing this constantly. Today, we will explain the results of the dust density measured over the reactor buildings and how we evaluate the current emission amount of radioactive materials based on the results. First of all, I will explain how we check the emission amounts and their variation. Since July, we have been evaluating the emission amount of radioactive materials from the reactor buildings. As in the first 2 months, we could not conduct samplings over the buildings. We evaluated the emission amount by measuring the density of radioactive materials in the air in the site and assuming that the radioactive materials are from the reactor buildings. As we measure at the west gate every day, we conduct evaluations by analyzing the radioactive materials in the dust in the air at the west gate. The Gaussian diffusion model is the concrete evaluation method being used, which was shown on page 5 below in the handout in the presentation on July 23rd, titled The Evaluation of Exposure Dose Due to the Measured Density of Radioactive Materials. The solution on the left part of this formula is the measured density of radioactive materials at the west gate. The emission rate and how they are emitted from reactor buildings are indicated by capital Q, and the way we calculate Q from the solution inversely is what we did on July 8th. With respect to the other items, since they are location information, if we can obtain the location relationship between the reactor buildings and the west gate where the measurement is conducted, the values will be constant and we will be able to figure out the value of Q with a conversion factor even if the solution varies. Actually, the evaluation results of the measurements in July are the emission rate per second, 1.4 times 10 to the 5th power becquerels per second. This is the way we conducted measurements in July and August. That is, we assumed the values based on the results of the measurement at the west gate, but since September, in order to evaluate with greater accuracy, we have decided to conduct samplings at points closer to the radiation emission source. First of all, we use a crane to suspend a dust sampler over the reactor buildings and, based on the evaluation results of the measurement by the sampler, make an assumption. In order to make a comparison, we also conduct samplings over the sea mentioned above and evaluate the impact of the soaring of the radioactive materials. Finally, we have been announcing the result of the measurement based on the evaluation results over the reactor buildings. We got the impression that the radioactive materials are being emitted from the reactor buildings. However, as of July 8th, we measured and evaluated the dust in the site border on the assumption that the dust was dispersed from the reactor buildings. On the other hand, since September, it has been possible for us to take samples directly over the buildings, and now we are conducting evaluations based on the results of these samplings. With regard to Unit 2, as the primary containment vessel management system has come into operation and directly pulls gases inside the vessel, we can now use them to evaluate rare gases. In the rightmost side, there is a description concerning the dust density over the sea. We measure it because the measurement on the sea is not affected by fallen radioactive materials that are carried by the wind, which happens in the case of radioactive materials that have fallen on the ground. I will now explain how we evaluate the densities unit by unit. First of all, as shown in the lower right-hand drawing, the reactor buildings are now covered, and therefore there are 3 measurement points. The first one is to check the emissions amount from the upper part of the reactor buildings. The second one is to measure the emissions from the big apertural areas known as the equipment hatch in the reactor buildings that run from the 1st floor to the 5th floor. And the third one is that we evaluate how many radioactive materials are observed in the entrance of the green lines in the reactor covers through which air is ventilated. Currently, the emission amount from the reactor buildings is being evaluated. At the entrance of it, the first one plus the second one minus the third one. Next, I will explain the data and formulas. First, as the upper part of the reactors is directly covered, we used the figures for October 17th, that is 2.00 million becquerels per hour. Then, as for the inside of the equipment hatch, we suspend with a crane the dust samplers at the apertural areas that correspond to the 4th floor of the reactor buildings and measure the dust densities. The result is 1.7 times 10 to the negative 4th power per cubic centimeter. And the airflow of the equipment hatch is approximately 12.5 cubic meters per second. With these numbers, we assume that approximately 6.00 to 8.00 million becquerels per hour of radiation is emitted through the equipment hatch. We calculate 3.00 million becquerels per hour for the removal amount per the emission equipment of the third cover, multiplying 12.4 cubic meters per second of the airflow with the entrance dust density. If you evaluate this with the above-mentioned formula, the first one plus the second one minus the third one. As for Unit 1, you get approximately 5.00 to 7.00 million becquerels per hour, and we have evaluated 10.0 million becquerels per hour.